Hello guys, welcome to the Doubtlet. So in this question, we are gonna find out the work done between the 2 points by the vector field that is given, and the coordinates of the both points are also given. So first of all, we have to write the vector field like in the x, y and z format. 6x, 6y and 6z. So here we can take 6 out common out from all the three, that is x, y, z. We know that work done is equal to f dot dr along the curve. So here curve is, let's assume this point as P1, and we will draw a straight line between the 2 points. This point is P1, this point is P2, and P1 coordinate are given as this and P2 coordinates are given as this. So as 3-dimensional coordinates are given, then we have to find the equation of this line in parametric form. So equation line in parametric form. We will use the 3-dimensional formula for this. Like this line is passing through both of these points, then we can take P1 as the point through which the line passes, then we will write x minus 1 divided by the direction ratio. Direction ratio we can obtain by subtracting the coordinates of point 2 minus point 1. Then the x coordinate will be 6 minus 1 is equal to y minus 3 divided by 7 minus 3 is equal to z minus 4 divided by 8 minus 4 and equal to t. Then we can easily write the parametric coordinates as rt is equal to, this is 5t plus 1 comma, this is 4t plus 3, and the value of z will be 4t plus 4. So from here we can find out the derivative of this parametric equation. R dash t, this will be 5, this will be 4 and this will be 4 and dt, and value of t varies from 0 to 1. So here we have to transform this vector field function in the form of parametric coordinates. F rt is equal to, we can replace x by 5t plus 1, y by 4t plus 3 and z by 4t plus 4. Like 6 is common from all of these, then it can be written as 5t plus 1 comma 4t plus 3 comma 4t plus 4. Now this is the force field vector in parametric form, and this is the equation of line. Then we know that work done is equal to f of rt, this is the force field vector, dot r dash t dt, and integration from 0 to 1. Now we have to find out the dot product of these two vectors. So to find the dot product, we have to just multiply the corresponding coordinates. So 6 will be taken out as the common, so this will be written as 0 to 1, and like 5t plus 1 into 5, this is 25 t plus 5, then 16t plus 40, 16t plus 12 plus 16t plus 16, 16t plus 16 and dt. Now we have to solve this. Integral from 0 to 1, this is 25t, 16, 16, 32, 32 plus 25 is 57. This is 57t plus 32 plus 25, like we can add it here, 57. And we have to just add up the constant terms. 5 plus 12, 17, 17 plus 16, 33, and dt. Now it is a linear integral, so we can easily integrate this, like 57t square divided by 2 plus 33t, and 6 is the constant here, so limit varies from 0 to 1. Then we can easily say this as 3 multiplied by 57 plus 33 multiplied by 6. Minus 0, so this will be the value. Now we have to solve this. 3 7 21, 3 5, this is 171 plus 198, and by adding up this, so work done will be, this will be 9, this will be 6, this will be 3, so work done will be 369 joule. So joule I am taking it at a unit, but if the unit are something else, then we can change in MKS or any other format as desired. So here this is the answer. One more thing I would like to tell you, that work done does not depend on path, it depends on the displacement. Like if the particle move either from this path or any other path, so the work done will be same in case of all the paths. So here, because of that, we will draw a straight line, because it is easy to find out the parametric equation of a straight line in 3 dimensions. If you would like to ask more such doubts, then please visit our website and post your doubts. Either you can write down your doubts in the comment section below. Thank you very much.